Okay, so the key thing here in just using the more direct approach to working out our derivative is this rule here. If we have some polynomial expression kx to the n, so 2x cubed, 3x squared, whatever, the derivative f dash of x is equal to n, so the power comes down and we subtract 1 from the power. Okay, so that's the most crucial thing. We just multiply by the power and subtract 1 from the power. So if we just look at these examples here, we've got the power is 5, so multiply by the power, take 1 from the power. 5 minus 1 is 4. 3 multiplied by the power, which is 3. 3 times negative 4 is negative 12. X, 3 minus 1 is 2. Take 1 from the power. In reality, the constant 1 is 1x to the 0. So if the 0 comes out the front, we multiply by 0, I just get 0. Okay, so therefore we're going to say that the derivative of x to the 5 minus 4x cubed plus 1 is 5x to the 4 minus 12x squared. All right. In 8, we'll use a little bit of notation because I've got the function f of x. The derivative f dashed of x is equal to multiply by the power here, which is 3. So I get 3 3s are 9. X, take 1 from the power. 2 times negative 6 is negative 12. X, 2 minus 1. Take 1 from the power, and again we spoke about the constant there is 0, so I get f dashed of x is equal to 9x squared minus 12x. Now it wants me to evaluate the derivative at 2, so that just means sub in x equal to 2, so f dashed of 2 is equal to 9 times 2 squared minus 12 times 2, which is 9 4s are 36 minus 24, which is equal to 12. So that's really saying the gradient is equal to 12 at x equal to 2. So it must be quite a steep line. Example 9, find the gradient of the curve. All right, so that means find f dashed of x. Okay, because f dashed of x is the gradient of the curve. It's the most crucial thing in this whole topic. It's the gradient of the curve. All right, they're the same thing. All right, multiply, well, we've just done this one. 3 times 3 is 9, so f dash of x is equal to 3 by 3 is 9, take 1 from the power, which is 2. 2 times negative 6 is negative 12. X, take 1 from the power, which is 1. And we spoke about the constant 1 being a derivative of 0. At the point x equal to 1, so that's the crucial thing here. That's saying x is equal to 1. I know y happens to be negative 2, but that's okay. We don't need to use that. So f dashed of 1 is equal to 9 times 1 minus 12 times 1. 9 minus 12, which equals negative 3. All right. So we can use an alternative notation, all right? So Leibniz, did I reckon I said Laplace? Leibniz was another man that created calculus. So he uses the notation y equals x cubed. So then the derivative of y, dy, with respect to x, dx, is equal to the derivative. It's the same rule. 3 comes out the front, take 1 from the power. So all it is a different notation. And so then if we happen to have a derivative with z and t, we work out dz dt. All right. We just make this a bit bigger. So we can see there, if y is equal to t squared, well then the derivative is dy dt, and that's just equal to 2t. For b, again, we've got x and t, so the derivative is dx dt, which is equal to 3t squared plus 1. All right. Z and x are the variables, so it's dz dx. And it's 3 multiplied by the power, 3 13s are 39, x, take 1 from the power, which is 2, plus 2 at the front, 2 times 1, which is 2, x, take 1 from the power, which is 1. All right, so the derivative in this case is called dz dx because they're the variables I've got. Example 11, we might expand those expressions first. So we might write y equals x squared plus 6x plus 9. Okay, remember to expand it properly. So then y and x, dy dx is equal to 2x plus 6. Similar for b, let's expand the first term first, say there in blue. That's 4t squared minus 4t plus 1. And that would be just multiplying by t plus 2. So now if I expand that through, I'll get z is equal to 4t cubed minus 4t squared plus t. Now multiply everything by 2 plus 8t squared minus 8t plus 2. Group everything together. I've got only one lot of cubes. Minus 4t squared plus 8t plus 4t squared plus t minus 8 is minus 7t plus 2. So now I can work out my derivative, which is dz dt. So the 3 is the power times 4, which is 12. Take 1 from the power, which is 2. 2 times 4 is 8t. Take 1 from the power is 1. 7t to the 1 is just 1 times 7t to the 0, and t to the 0 is 1, so that becomes a constant. 2 is 0. All right, so there's my derivative dz dt. Finally for c, again, just dy dx. 2 times x is 1, so 2x plus 3. Again, it's a dy dx because the variables are y and x. 3 times 2 is 6. 6x, take 1 from the power is squared, and the derivative of 1 is just 0. So there's my derivatives there. The final kind of notation, okay, is where they sort of have dy dx. It's almost like the notation our calculator uses, where instead of putting dy dx, instead of putting a y there, they just put the rule that we have to differentiate. Okay, so in this case then, the derivative of 2x cubed minus 4x with respect to x is how we would say it. And that's simply equal to, well, 3 by 2 is 6, x squared minus 4. For b, 2 times 2 is 4, z minus 3. And again, 2 times 2 is 4z minus 12z squared. Okay, so the notations are different, but the processes are the same. Finally, if we have a little sort of application kind of question, find the coordinates of the points on the curves determined where the gradient has a given value. So we try to find a point on the curve. So I'll just sketch this first graph. So if we have a little axis and it's a graph of y equals x cubed, okay, and we're saying, well, whereabouts is the gradient equal to 8? So whereabouts do we have a really big positive gradient? So maybe it's there somewhere. Looks like there's 2 spots. So we need a rule for the gradient. A rule for the gradient is my derivative. So we need dy dx, which in this case is 3x squared. Whereabouts is the gradient 8? So that means I need to solve 3x squared equal to 8, because don't forget this expression here could easily be where m is the gradient. Yeah. So now if I solve that, I get x squared is equal to 8 on 3, so x is equal to plus or minus the square root of 8 on 3. By each of the following equations, so we've got to find the coordinates of the points. So I know that at x equal to positive root 8 on 3, and x equal to negative root 8 on 3, we have a gradient of 8, but I need to find the corresponding y value. So at x equal to root 8 on 3, y is equal to, well, we'll put that into square root of 8 on 3 cubed. So probably in some ways helps if we simplify the square root of everything, I should say. Look, I think in reality, so that's x to 8 on 3 to the half, isn't it? So 8 on 3 to the half, all times 3 is 8 to the 3 on 2. So my coordinate would be positive 8 on 3 to the half, 8 on 3 to the 3 on 2. So then my other coordinate, I won't put it there. My other coordinate, I might just change the colour, is going to be at negative square root of 8 on 3 and negative 8 on 3 to the 3 on 2. So I'm sorry about that, it's a little bit tight for room. All right, so let's think about B. I want to find the spots on that curve where the gradient is 0. So the rule for the gradient is dy dx, and in this case that's equal to 2x minus 4. So the gradient is 0, that means dy dx has to equal 0. So if I solve 0 equal to 2x minus 4, I get 4 equal to 2x, x is equal to 2. And so if x is equal to 2, y is equal to 2 squared minus 4 times 2 plus 2. So y is equal to 4 minus 8 plus 2, which is equal to negative 2. So 2, negative 2 is where the gradient is 0. And if we think about the graph of that function, well, it's a parabola. And if I complete the square on that parabola, that's the graph of x minus 2 all squared, plus 4 minus 4 plus 2, which is minus 2. So it's got a turning point at 2, negative 2. So it might look something like that. And that turning point corresponds to where the gradient is 0. And that's a really important application of the derivative. So what about for y equals 4 minus x cubed? Whereabouts is that derivative? Sorry, whereabouts is that gradient negative 6? So again, that just simply means dy dx has to equal negative 6. So dy dx is equal to negative 3x squared. And we have to solve that. Negative 6 equals negative 3x squared. 2 equals x squared. So x equals plus or minus the square root of 2. So I need to find the coordinates. So therefore, at x equal to positive root 2, y is equal to 4 minus root 2 cubed, which is equal to root 2 cubed is root 2 by root 2, which is 2, times root 2, which is 2 root 2. So my coordinate will be root 2, 4 minus 2 root 2. And at x equal to negative root 2, I'm going to get y equals 4 minus negative root 2 cubed. So y is equal to 4 minus 2 root 2, which is 4 plus 2 root 2. So I get the point negative root 2, 4 plus 2 root 2. Okay, so really important little section of work. Finding the gradient is one thing, and I think we'll get better and better at that. Using the gradient and using the derivative, I should say, so finding the derivative, which is finding the gradient rule, is one thing. Using it is the one that we need to really practice.